ನಮಸ್ಕಾರ. ಇವತ್ತು ನಾವು ನ್ಯೂಮರಿಕಲ್ ಟೆಕ್ನಿಕ್ಸ್ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡೋಕೆ ಬರ್ತಾ ಇದ್ದೀವಿ. ಸೊ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಟೆಕ್ನಿಕ್ಸ್ ಅಥವಾ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಮೆಥಡ್ಸ್ ಅಂತ ಬಂದಾಗ ಯೂಶುವಲಿ ಎರಡು ಮೇಜರ್ ಟೈಪ್ಸ್ ಬರುತ್ತೆ, ಅನಾಲಿಟಿಕಲ್ ಮೆಥಡ್ ಮತ್ತು ನ್ಯೂಮರಿಕಲ್ ಮೆಥಡ್. ಅಪಾರ್ಟ್ ಫ್ರಮ್ ದಿಸ್ ಟು ವಿ ಹ್ಯಾವ್ ಫ್ಯೂ ಮೋರ್ ಟೈಪ್ಸ್, ಗ್ರಾಫಿಕಲ್ ಮೆಥಡ್ ಆ್ಯಂಡ್ ಸೋ ಮೆನಿ. ಸೊ ಮೇಯ್ನ್ ಆಗಿ ಹೇಳುವಂಥದ್ದು ಅನಾಲಿಟಿಕಲ್ ಮೆಥಡ್ ಮತ್ತು ನ್ಯೂಮರಿಕಲ್ ಮೆಥಡ್. ಇಲ್ಲಿವರೆಗೆ ಏನು ಓದಿರ್ತೀವಿ ಯೂಶುವಲಿ ನಮ್ಮ ಸ್ಕೂಲ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸಿಂದ ಟಿಲ್ ಬಿ ಅಥವಾ BSc ಇಲ್ಲಿ ಡಿಗ್ರಿ ಲೆವೆಲ್ವರೆಗೂ ಏನು ಓದಿರ್ತೀವಿ ಅದೆಲ್ಲ ಅನಾಲಿಟಿಕಲ್ ಮೆಥಡ್. ಸೊ ಅನಾಲಿಟಿಕಲ್ ಮೆಥಡ್ದು ಪ್ಲಸ್ ಪಾಯಿಂಟ್ ಏನಂತಂದರೆ ದಟ್ ಗಿವ್ಸ್ ಆಲ್ವೇಸ್ ದಿ ಎಕ್ಸಾಕ್ಟ್ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ದಿ ಪ್ರಾಬ್ಲಮ್. ನೀವು ಯಾವುದೇ ಪ್ರಾಬ್ಲಮ್ ತಗೊಂಡ್ರು ಅದರದ್ದು ಸೊಲ್ಯೂಷನ್ ಏನು ಎಕ್ಸಾಕ್ಟ್ ಸೊಲ್ಯೂಷನ್ ಕೊಡುತ್ತೆ. ದಟ್ ಈಸ್ ದಿ ಅಡ್ವಾಂಟೇಜ್ ಆಫ್ ಅನಾಲಿಟಿಕ್ ಮೆಥಡ್. ಸೊ ನೆಗೆಟಿವ್ ಪಾಯಿಂಟ್ ಆಫ್ ಅನಾಲಿಟಿಕಲ್ ಮೆಥಡ್ ಈಸ್ ನಾಟ್ ಎವರಿ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವಬಲ್. ನೀವು ಎಲ್ಲ ಪ್ರಾಬ್ಲಮ್ಗೂ ಸೊಲ್ಯೂಷನ್ ಕಂಡುಹಿಡಿಯೋದಕ್ಕಾಗಲ್ಲ. ಸೊ ಐದರ್ ಇಟ್ ಗಿವ್ಸ್ ದಿ ಎಕ್ಸಾಕ್ಟ್ ಸೊಲ್ಯೂಷನ್ ಆರ್ ಇಟ್ ಸೇಸ್ ಇಟ್ ಹ್ಯಾಸ್ ನೋ ಸೊಲ್ಯೂಷನ್. ಒಂದು ಎಕ್ಸಾಕ್ಟ್ ಸೊಲ್ಯೂಷನ್ ಕೊಡುತ್ತೆ, ಇಲ್ಲ ಸೊಲ್ಯೂಷನ್ನೇ ಇಲ್ಲ, ಎರಡೇ ಕೇಸಲ್ಲಿ ಬರೋದು. ಸೊ ದಿಸ್ ಇಸ್ ದಿ ಪ್ಲಸ್ ಪಾಯಿಂಟ್ ಅಂಡ್ ದಿಸ್ ಒನ್ ಇಸ್ ದಿ ಮೈನಸ್ ಪಾಯಿಂಟ್. ಸೊ ವೆನ್ we come across with some problems which has no solution using analytical method, then we move on to numerical method. The plus point of numerical method is every problem has solution with this method. So using numerical method you can find the solution of any problem irrespective of the difficulty. But the negative point of this solution is in most of the cases it gives only approximate solution. So when the exact solution exists, then numerical method also gives exact solution, same as analytical method, no problem. When exact solution is not possible, it gives the approximate solution, and the accuracy can be achieved by repeating the process again and again. So then only we can get the accurate one. So anyway, we don't get exact solution, but we get approximate solution. That is the positive point of negative point of numerical method. We don't get exact solution, but it can also be treated as positive point because we get at least approximate solution. So here under numerical methods we are going to start with finite differences, the base of numerical method. So let us see how to find the finite differences. So here we will consider a function y equal to f of x. As usual, x is the independent variable, y is the independent variable. As you give different values for x, y takes different values. Here we take the values for x as x0, x1, x2 and so on xn. All these values are equidistant. So first value will be x0, then x0 plus h, that will be x1, x0 plus 2h will be x2 and so on. x0 plus nh will be xn. So this will be x1 plus nh. So these are equidistant. So if you take any two consecutive terms, the difference will be h. Corresponding to the values of x0, we will be having corresponding functional values y0, y1 and so on yn. This is the functional value corresponding to x0. This is the functional value corresponding to x1 and so on. Now we are going to define first forward difference of y equal to f of x. So first forward difference of y equal to f of x is denoted by delta f of x. This is the notation for first forward difference, and is defined to be the first forward difference of y equal to f of x is defined to be delta f of x equal to f of x plus h minus f of x. Now we have these values x0, x1 and so on xn, corresponding functional values y0, y1 and so on yn. If I take x0 in place of x here, I get delta f of x0 equal to f of x0 plus h minus f of x0. But x0 plus h means x1. So delta f of x0 will be f of x1 minus f of x0. Similarly, you can find delta f of x1. Delta f of x1 will be f of x1 plus h minus f of x1. That will be f of x2 minus f of x1. If you continue in that way, we will be having finally, you cannot define the forward difference for xn, because on the right hand side you may get f of xn plus 1. That is not available here. So the first forward difference can go up to only xn minus 1. So delta f of xn minus 1 equal to f of xn minus f of xn minus 1. If you are supposed to write this in terms of y, in terms of y ಬರಿತೀವಿ ಅನ್ನೋದಾದ್ರೆ ಏನಾಗುತ್ತೆ ಅವಾಗ delta y0 equal to y1 minus y0. Delta y2 will be, delta y1 will be y2 minus y1. Delta y3 will be y3 minus y2 and so on. Finally, delta yn minus 1 will be yn minus 1. Now, let us define the second forward difference. This is about first forward difference. Now we can define second forward difference. Who can we define second forward difference? Just take difference of first forward differences. Delta 2 f of x will be, see here we are having delta f of x equal to f of x plus h minus f of x. Just take delta on both sides. You get delta 2 f of x equal to delta f of x plus h minus delta f of x. Now, if I take x naught in place of x, I'll get delta 2 f of x naught equal to delta f of x naught plus h, that is delta f of x1 minus delta f of x naught. So delta f of x1, that will be f of x2 minus f of x1 minus of, now delta f of x naught, delta f of x naught will be, that is the first forward difference of f of x naught, that will be what? F of x1 with the negative sign I have minus of minus plus f of x naught. So I got delta 2 f of x naught equal to f of x2 minus 2 times of f of x1 plus f of x naught. If I write this in terms of y, delta 2 y naught will be y2 minus 2y1 plus y naught. That is the second forward difference of f of x naught. Similarly, if you take differences of second forward differences, you get third forward differences. Example, and this can go up to only delta 2 f of x n minus 2. Second forward difference. So we observe first forward difference x0 in the starting, x n minus 1 ಗೆ end ಆಯಿತು. Second forward difference ಬಂದ್ರೆ delta 2 f of x n minus 2. So 0 in the starting again n minus 2 ಗೆ end ಆಗುತ್ತೆ. So ಇದೇನಿರುತ್ತೆ statement right hand side we will be having f of 2 add ಮಾಡಿದ್ದೀವಿ. f of xn minus 2 times of f of xn minus 1 plus f of xn minus 2 ಬರುತ್ತೆ. Or in terms of y, delta 2 yn minus 2 will be yn minus 2 yn minus 1 plus yn minus 2. That's about second forward difference. Similarly, third forward difference, so that can be defined as third forward difference of f of x will be differences of second forward difference. Delta 2 f of x plus h minus delta 2 f of x. Similarly, you may define as you again here the difference goes from delta x naught to third forward difference, that is defined from f of x naught to up to xn minus 3 you can go. Third forward difference you may go up to xn minus 3. Similarly, fourth forward difference, that will be differences of third forward differences minus delta 3 f of x. This you can go from x0 to xn minus 4. So you can go up to nth forward difference. Nth forward difference, that is defined only for x0. Only nth forward difference of f of x0 we can define. Now all these values we can list in a table. That table is called first forward difference table of f of x. all these values we may list in a table. So see, I have this function y equal to f of x, and correspondingly I have functional values y0, y1, yn corresponding to x0, x1, xn. So to write the first forward difference table, so in the first column I have to write the values of x. First column, write down the values of x, that is fixed. Second column, write the values of y. Third column, first forward differences. Second forward differences. Third forward differences. And you can move up to nth forward difference. Now the values of x are x0, x1, x2, x3 and so on, xn minus 2, xn minus 1, xn. These are the values of independent variable x. Corresponding functional values y0, y1, y2, y3 and so on, yn minus 2, yn minus 1, yn. Now first forward difference, you have to keep this entry, first forward difference of y0, that will be y1 minus y0. So here I have to write delta y0, that is y1 minus y0. Next I have to write delta y1, that will be y2 minus y1. So next delta y2, that will be y3 minus y2. If you continue in this way, here you have to write delta, see, delta y2, delta y1, delta y0. So here I have to write delta yn minus 2, that is yn minus 1 minus yn minus 2. Next, here I have to write delta yn minus 1. y0 ಮತ್ತು y1 ಮಧ್ಯ ಅದರದ್ದು ಫೈನೈಟ್ ಡಿಫರೆನ್ಸ್ ಬರ್ತಿದ್ದಾನೆ, ಅದೇ ರೀತಿ ಇವೆರಡರ ಮಧ್ಯೆ ಇದು ಬರಬೇಕು, ಈ ತರ ಬರಬೇಕು. ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡ್ ಡಿಫರೆನ್ಸಸ್, here I should write delta y1 minus delta y0, that is the second forward difference of y0. ಇದೇ ರೀತಿ ಇಲ್ಲಿ delta 2 y1, ಇಲ್ಲಿ delta 3 y1 ಬರುತ್ತೆ. ಕಂಟಿನ್ಯೂ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ delta 2 delta 3 it is, delta 2 it is, delta 2 y2. ಹಾಗೆ ಕಂಟಿನ್ಯೂ ಮಾಡಿದ್ರೆ delta 2 yn minus 2. ಇಲ್ಲಿ ಇವೆರಡರ ಡಿಫರೆನ್ಸ್ ತಗೊಂಡ್ರೆ delta 3 y0, delta 3 y1, delta 3 y2 and so on. Here we will get delta 3 yn minus 3. And to continue this way, so finally we get delta n y in y0, nth forward difference of y0. And these values delta y0, delta 2 y0, y0, delta 3 y0 and so on, delta y0, these entries are called leading forward differences. Leading forward differences. y0, zeroth leading forward difference, first leading forward difference, second leading forward difference, third leading forward difference, nth leading forward difference. So forward differences table alli first entries of each column corresponding to y. So these entries are called leading forward differences. So similarly we may define backward differences also. So backward differences, let's again start with the definition. That idea is similar to forward differences, but we will be having very small difference between those two. There in the forward differences, leading entry get differences, where in the backward differences, the trailing entry, the last entry got a difference. Preference. Now first backward difference. Backward differences. As usual, suppose I have the function y equal to f of x. and I have the values x0, x1, x2 that are equidistant, xn, corresponding functional values y0, y1, y2 and so on, yn. x1 equal to x0 plus h, x2 equal to x0 plus 2h and so on, xn equal to x0 plus nh. They are equidistant. So if you take any two consecutive terms, the difference will be h. Corresponding to that, I have functional values y0, y1, yn. So ಮುಂಚೆ ಫಾರ್ವರ್ಡ್ ಡಿಫರೆನ್ಸ್ ಗೆ ಯಾವ ತರ ವ್ಯಾಲ್ಯೂಸ್ ತಗೊಂಡಿದ್ದೆ ಸೇಮ್ ಟೈಪ್ ವ್ಯಾಲ್ಯೂಸ್ ತಗೊಂಡಿದ್ದೀನಿ. ಸೊ ಫಸ್ಟ್ ಬ್ಯಾಕ್ವರ್ಡ್ ಡಿಫರೆನ್ಸ್. It is denoted by ulta ಬರೆಯೋದು delta. It is called del f of x and defined by and is given by del f of x equal to f of x minus f of x minus h. That is the definition of backward differences. Del f of x equal to f of x minus f of x minus h. Now we define backward differences for xn, x2, x1 and so on x0. So reverse order ಬರ್ತವೆ corresponding to forward differences. So here taking x equal to xn. Now f of xn equal to f of xn minus f of xn minus h. Xn minus h is xn minus 1. So it will be f of xn minus f of xn minus 1. So correspondingly I have del yn equal to yn minus 1. So similarly taking x equal to xn minus 1, f of xn minus 1 equal to f of xn minus 1 minus f of xn minus 2. So it will be, if you write this in terms of y, del yn minus 1 equal to yn minus 1 minus yn minus 2. You can continue this process. So finally you can define first backward differences till f of x1 only. For x0 it is not defined. So f of x1 will be f of x1 minus f of x0. So del y1 equal to y1 minus y0. Why it is not defined for x0? If you take x0 here, then f of x0 minus f of x minus 1 will be. But x minus 1 entry we don't have in the list. So the difference, backward difference, is defined till f of x1 only. Similarly, you may define second backward differences. How it can be defined? Second backward difference may be defined as the differences of first backward differences. So del 2 f of x will be del f of x minus del f of x minus h. And this one is defined till xn to x and x2. First forward difference is defined from x1 to x1, xn to x1. Second forward difference xn to x2. So the second backward difference is. And similarly third backward difference, del 3 f of x equal to del f of x, del 2 f of x minus del 2 f of x minus h. So it is defined from xn to x3. If you continue this, nth backward difference is defined only for xn. Again, as in the previous case, these values may be listed in a table, and that table is called as backward difference table for y equal to f of x. So as usual, first column I have to write the values of x, second column write the values for y. So values of x are x0, x1, x2 and so on, xn minus 3, xn minus 2, xn minus 1, xn. Corresponding to that, y0, y1, y2 yn minus 3, yn minus 2, yn minus 1, yn. So these are the values of x and y that we have studied. Next, del y, y1 minus y0, y1 minus y0, that is first backward difference of y1. So here I have to write del y1, del y2, y2 minus y1. Here we continue in this way. Here I will get del yn minus 2. That is yn minus 2 minus yn minus 1. Del yn minus 3. Yn minus, n minus 1 it is. Del yn minus 1. Yn minus 1 minus yn minus 2. Del yn minus yn minus 1. Next, second backward differences. Del y2 minus del y1, that will be del 2y1. So then it will be del 2y2 ಬರುತ್ತೆ. Continue ಮಾಡ್ತಾ ಹೋದ್ರೆ, sorry, it will be del y2 ಬರುತ್ತೆ. ಇದು y3. If you continue this way, here del 2 yn minus 1, del 2 yn. Next, third backward differences, del 3y. So here you get del 3y3. Next here you will be having del 3y4 and so on. Here del 3yn. ಇದರ ಮೇಲ್ಗಡೆ del 3yn minus 1 ಇರುತ್ತೆ. So continuing in this way, nth backward difference, that you will get del n yn. So yn, del yn, del 2yn, del 3yn, and so on, del n yn. These entries are called leading backward differences. These entries are called leading backward differences. So it is actually, this one is zeroth leading backward difference, first leading backward difference, second leading backward difference, third leading backward difference, nth leading backward difference. So the trailing entries or the last entries of the table are called leading backward differences. This is about the first, finite differences, forward differences and backward differences of the function y equal to f of x. So in both the cases, we will be having, actually if you write the table, that will be clear. In both the cases, we will be having same entries, but the way we are looking at that entries will be different. So let us take an example and